Okay, so we're going to look at the different ways that you can apply, okay, logs to solve problems. So how long would it take 5,000 to increase in value to 6,000 if invested in a credit union at a yearly compound interest rate of 2%? So from Junior Cert, do you remember your formula? F equals P 1 plus I to the power T. Okay, so that's your compound interest formula. Your final amount, your principal is the amount you put in, I is your interest, T is your time. We're going to be finding what T is, okay? And we'll use logs to do it. So we're looking to invest 5,000 and we want it to increase to 6,000. So what's your F? 6,000. That's the final amount. 6,000 equals P, the amount you put in, the principal. 5,000. 1 plus I, so that's 1 plus 2%. That's either written as a decimal or a fraction, okay? To the power of T. So 6,000 equals 5,000, just tidy it up a little bit. 1.02 to the power of T. Now I'm interested in finding the power. So that means I need to try and get this part on its own. Where does that 5,000 go? Under. Okay, 6,000 over 5,000 is 1.2. From here, you can use logs, okay? Base, power, value. So remember this. You're using logs for when you're trying to find the power, okay? So I have this, and I need to convert it to a log. There's my base. So log to the base 1.02 of 1.2 gives me the power. Okay? Base, power, value. And all I'm going to do is throw that into my calculator. So log to the base 1.02 of 1.2, and I get T is 9.21, okay, years. So this is where it becomes important to use logs, because you're looking for the power. If ever you're looking for the power, you've got to use logs. So once you get here, you're thinking, okay, what do I have? I have a base, I have a power, I have a value. Okay, log to the base 1.02 of the value gives you the power. Okay, so that's one application of it. Will you do another? Can I get rid of the board? Yeah, straight into the calculator there, like that. For these problems, you're looking for the power. Okay, so the T, or it's normally time in this, but it could be X, it could be anything, but you're looking for the power. Okay. Okay, example 2.
Population of the world.
And yeah, so like they predict, like coronavirus at the minute, they're predicting the numbers using things like this. Yeah. So rather than using a linear graph, there's a log graph, which is much more accurate. The population of red squirrels in a given region was estimated to be 5,000 at the start of 2003. Assuming a rate of decrease of 5% per year, estimate the size of the population in 2013. Now, it's almost the exact same formula, except what's happening? It's decreasing, so it's minus. Excellent. It's like your depreciation formula from junior cert. F equals P1 minus I to the power T. Now this time they've actually told me the power. They've told me how many years. Okay, so I might not need to use logs for this. So let's just have a quick look. So a rate of decrease of 5% per year, estimate the size of the population in 2013. How many years have passed? 10. Okay, so you're just going to go to your formula. What was the original? 5,000. Okay, we're looking, assuming a rate of decrease, estimate the size of the population. We're looking for F. One minus, so 5% to the power of how many years? 10.
Is the principal the starting?
Yeah, the starting. Yeah, exactly. So 2993.7 squirrels, so 2994. So we're just applying these exponential and log functions to real world problems, okay?
How did you know it was minus I?
Because it's telling me that it decreases. Okay, so it's reducing each time, so then it's a minus. Okay? Let's do a few more. Yeah.
Would stuff like this be coming from our test on Friday?
Yes.
Well, I can't remember any.
How did this?
Oh no, this is literally it now. They're the two.
They're the only questions.
So I'll do another one now, and we'll learn that as well. And they're the kind of three formulas that normally they give them to you though in the question. Okay? And these are in your log tables as well, by the way. F equals P1 plus I and 1 minus I.
Is that the depreciation program?
Exactly, depreciation, yeah. Let me just find you the page. So they're both on page 30. Okay, of your log tables. Tell me when I can get rid of the board. Yeah? Okay, another one. This one would be quite common.
Excuse me, please, would the following go to the staff room at the Bell? Amelia Bienert, Libby Costello and Arna Maheshwari. Thank you.
Is that a B or a C?
That's a B. P equals AE to the power of BT. Okay, scientists have shown that a particular population of insects grow exponentially according to the model P equals AE to the power of BT. Okay, where A and B are constants and T is time measured in weeks. A remote area of forest has a population of 500 of these insects. In 1 week, the population increases to 560. Find the value of A and B. What was the population of insects at the beginning? 500. How many weeks had passed when it was at 500? None. No weeks. So what's your T? 0. Very good. That's really important. At the beginning your T is 0 and that's going to help you to find A and B. Okay? So at the beginning the population was 500. You're always going to try and fill in that T is 0. If they give you an initial value or at the beginning, okay, at the start, your T is 0. Now, what's B by 0? 0. What's E to the power of 0?
1.
Anything to the power of 0 is 1. Perfect. So 500 equals A by 1. So A is 500. Same thing again and fill in what else you know. So I know that A is 500 now. So they gave me some more information. In 1 week the population increases to 560.
So you put in the T.
Put in T is 1 and the population is 560. So what's the population? The letter P. So 560 equals 500 E B 1. T is 1. 1 week. So 560 equals 500 E to the power B. How do I get E to the power B? Remember, E is just a number. Okay, it's just a decimal. So I'm interested in getting the power B. So what will I have to use to get a power? Logs. Great. Where does that 500 go? Under. So that's 28 over 25 when I just tied it up equals E to the power of B. Now, I am looking for a power, so I need to do logs. What's my base?
28 over
E. Yeah, that's your base. Base. What's my power? B. Value. Okay, base, power, value. So log to the base E of 28 over 25 will give me B. Log to the base E, another way of saying that we said was ln. Okay, so on your calculator here you have an ln, or you could still use this and look for E. E is down there and pink, so alpha, log to the base E, but I'm just going to use ln because I know that's log to the base E. 28 over 25, and I get B is 0.11. Okay. Now, did they ask me for find the value of A and B? No, they didn't tell me what to put it to. Okay, so I'm going to go just a few more decimal places there to be a bit more accurate. 0.1133. Okay, so that's my answer to part 1. There's the value of A. There's the value of B. Is there any issues with that?
How did you find B with that finding
E is a number. Okay, E is like pi. It's just a letter that stands for a number. So if I go alpha E, E is 2.71828 . Okay?
Yeah.
So that is just a number. So I don't need, like, I can fill in the decimal, but there's no point. Keep it as e the whole way along. Okay, so that's just a number to the power of b. So that's just my base. My base is the e there. Okay? Here? So b by 0 is 0. Yeah, so like nothing by b is nothing. And then e to the power of 0 is 1. Anything to the power of 0 is 1. Okay? Now part 2. Find the time it takes for the population to increase to this. What do we do? Fill everything in, lovely. Okay, so the population would be that number. Okay, that's my P. So I'm here. I'm saying 181,262 equals, I know that A is 500 and B is 0.1133T. I just filled in my A and my B. Now, again, I'm looking for a power. Where does that 500 go? Under. I'm looking for the power, so what do I have to use? Logs. So before tidying any of that up, because we don't have time, I'm just going to say log to the base e of this thing, and that can all go into your calculator, is going to give me the power. Okay, so log to the base e of 181,262 over 500. So that's 5.893 is 0.1133. And how do I get what t is? Where does this 0.1133 go? Under. Okay. Yeah, the very first bit. Base power value. So log to the base e of the value gives you the power. Okay, so I'm just going to divide by 0.1133 and I'm going to get my t. So 52 is t. Okay, so to the nearest week, it takes 52 weeks.
Is that, did you go there and then over there?
Here and then here.